Hello everyone! Today's top 6 list is why Looker users love to use Ascend. My name is Tom, and joining me for the demo portions of our video will be my colleague Sheil. To get started, I'll give you a little context about where Ascend fits in the Looker ecosystem. If you are a Looker user, you're very familiar with this slide that shows Looker interacting with a SQL database or data warehouse that's housing data from a variety of mostly relational data sources. With Ascend, you open up the entire world of big data, IoT and streaming, and web analytics, as Ascend can ingest and transform that data before handing it off to Looker, or optionally loading it into the data warehouse or database to which you currently have Looker connected to. Fantastic. Now off to the top 6 list. Number 6. Any data source, anywhere. If we can get to it, we can ingest it. We have native connections to common data sources and the ability to write small Python snippets to bring in anything else. Now over to Sheil for a quick demo. Now clearly that's not Sheil, but cookies are like data sources to us. We love them and we eat them up. Number 5. Pipeline visualizations. Ascend has a modern DAG-based GUI interface that simplifies complex queries into easy to understand sequential operations. Through this GUI, you can also see metadata and state information about your transformations and data pipelines all at a glance. This time, Sheil for real.
Thanks, Tom. Here we can see in Ascend that a complex SQL query can actually be laid out as separate chunks. For example, with our green-cap data here, we're first cleaning it up, and then we're unioning together the incremental data set with the historical data set. And by seeing it as separate components, this gives us the ability to investigate and see what's going on. That first we have these 4.68 million records that are all getting cleaned up, and then adding that together with these 4.15, we get 8.83 million records. So it looks like, overall, with these SQL statements, there's nothing wrong with our transformation. We even have the ability to dive into the records of one particular SQL node. In this SQL statement, as we know that we're just cleaning up the green cap data, we can see that we're adding something like a current timestamp and cleaning up some columns. But in Ascend, we have the ability to also start looking at exactly the records that we're working with. This is the full set of data. Regardless of if it's million records or billions or trillions of records, this is not a sample. We can scroll down and look at the full set of data. We can also even write queries against this intermediate data set.
Thanks so much, Sheil. Number 4. Data quality. Who doesn't have a problem with this? With Ascend, you can easily explore and validate your data before handing it off to your reports or to your analysts. Back to you, Sheil.
Thanks again, Tom. Even though we have a sense of the number of records that are flowing through the system, this doesn't help us understand the quality of data. Luckily, Ascend is profiling the data all along the way. So we can open up any one of these SQL components, and we can take a look at the data profile as well. Going through the different columns here, we can see that we have some cab type, some drop-off date times, but the fair amounts, looks like we have some problems there. We're seeing negative values on some of these record sets. Let's figure out how big of a problem that is by querying this component and finding all the negative fair amounts. Go here and query this component, and we can go ahead and write a count star as the bad records, where the fair amount is less than 0. Simply running that and querying this data as we're bringing it through the pipeline will give us a sense of how bad the data is and if we just want to discard these records, still coerce them, or do something else about it. Looks like we've got 9,000 of them out of a full set of 8 million. That's not too bad. I think for right now what we should do is we'll go ahead and discount these records. So we're going to just remove them from the data set by selecting all of the records that we do want and making sure that the fair amount is greater than 0. We can double check that query by writing a quick limit. We can see that Ascend has already figured out the schema while it's still chugging through the data. And we can see here now that this set looks pretty good. So let's go ahead and remove the limit, and we can save that as a transform into our production data flow. We'll call it valid cab records. And by simply hitting create, we can see that it's been added to our graph, it's already started to run, and soon it'll be up to date, just like all the other components.
Thanks, Sheil. On to number 3, adaptive ingestion. What a cool term. Ascend solves a number of common schema problems, including cascading schema changes into the data warehouse automatically. We can also alert the data team with configurable levels of notifications when breaking changes are detected. Once again, over to Sheil.
Back to the data flow, we can see that we've wired up this node to write into Redshift and Snowflake. With Ascend, we can automatically keep these downstream syncs, like any warehouse, or even directly just straight into S3 for other machine learning or data science use cases, up to date by simply adding one of these write connectors. In fact, with these write connectors, we have the option of also keeping the schema automatically managed. That in order, if there's any schema mismatch, we can go ahead and adapt to schema change, even fixing up any type mismatches or dropping any odd columns that have maybe made their way in there. Let's check out what that looks like. By going into the SQL node, I can go ahead and add a column that we want in our database, such as editor. We'll add that to our group by, and I'll hit update. Looks like Ascend has already recomputed with that, and we've added in a new editor. And then Ascend has gone ahead and started to restage Redshift and Snowflake, adding this new column into the data warehouse. And once these are up to date, we'll have that new column as well as all the historical data filled in already. If there's a fatal error in your data or in any of your code logic that you've written, and you want to be notified about it, you can go to Data Service Settings and Notifications, and simply add a new notification where we can send an email or a Slack message for anything that's going on in your Ascend environment, in the data flow events, or in the system processing events, for anything that might be going into error state.
Thanks again, Sheil. Number 2, data lineage. We allow you to easily answer the question, how is this field derived, through the visualization of lineage that shows all calculations and operations done to the data. We can do this upstream or downstream. Demo please, Sheil.
Here's the lineage of tracing through the sum total amounts, one particular column of our daily write data. We can see that it's coming from this line and this column, which is actually coming from a SQL function running a sum on the total amount, and we can keep going through that way, tracing all the way up to the input source data. And as a reminder, we can see that it's coming through the union data set, as well as it includes the yellow cab data set. From the first upstream source, from the original raw source of the data, we can see that the green cab data is using the total amount column, but we actually have a small bug on the yellow cab data that is using the tip amount. That probably explains why our reports are a little bit buggy, and we should get that fixed up ASAP. Similarly, we can do a downstream impact analysis. From here, we can take the column tolls amount, and if we're thinking of maybe changing the definition of it, or we're thinking that maybe this column isn't so worthwhile, we can see how it's being used downstream in these particular transforms, all the way into its final data state as to where it's dropped off.
And finally, number 1, you get to play with cool stuff. Yes, no matter what your level of technical skill, we make the most modern capabilities accessible to you instantly. Play with Python, execute Spark jobs, and begin your data science and machine learning journey with no knowledge of the underlying infrastructure or applications required. Your last demo, Sheil.
With Ascend, if you do need further capabilities, such as writing Python, you can also create a PySpark component. In this one, I'll show a simple example of a machine learning algorithm just using a more simple logistic regression model. We can see here that without having to know all the underlying pieces of how to spin up a Spark session to do machine learning or deal with any of those types of complexities, That's simply all passed into us as the user. And it feels like a familiar interface similar to a pandas data frame, where you get a list of Spark data frames inputted, and we can start doing some transformations. In this case, we're identifying which columns we want to featureize on, as well as then running a logistic regression example from PySpark. With that, we can see the output records and see how we were doing on fitting our model and training our model. With this send interface, you can intermingle between SQL transforms and PySpark transforms to do Python code in a totally safe space. There's no way to cause any type of collateral damage, of mutating any records outside of it, or losing any data set. It's a total safe space to just try whichever code that you need to try and get it productionalized.
And there you have it, the top 6 reasons why Looker users love to use Ascend. To recap, number 6, any data source anywhere. Number 5, pipeline visualizations. Number 4, data quality. Number 3, adaptive ingestion. Number 2, data lineage. And number 1, you get to play with cool stuff. Thanks for watching, everyone. Come visit us today at www.ascend.io and sign up for a demo or a free trial.